So this is Algebra 2 with Trig, Unit 1B.3. This is the second day. We are actually going to graph quadratics in standard form. So some different steps that we typically would use when graphing standard form is to first we need to find the axis of symmetry. We can also call that the LOS, which would be considered the line of symmetry. It means the exact same thing, axis of symmetry or line of symmetry. So we're going to be finding the line of symmetry as negative b over 2a. That finds the line that splits the parabola right down the center. Once we graph that line of symmetry, we put the dots on the paper. We are then going to find the y value of the vertex. The line of symmetry is the x value of the vertex. So the y value is going to be when you substitute the x value in. You substitute it into the equation, and you will find the y value. It's either the maximum or the minimum of the function. So then if we're using a table, you could plot those points onto a table. You put it in the middle column. And then you can pick values to the right and pick values to the left, and we can talk about calculating that out. Table's not my favorite, but we'll talk about it some. We will reflect a point. When we find a point without doing a calculation, but only using the line of symmetry, that is called a reflection point. And we can find reflection points by transferring our point across a line of symmetry. Here's a quick little video. If you would want to watch that at some point, I would suggest stopping at 2.8. 2 minutes, 8 seconds. So let's come on down and try this for the first one. We have this equation. We see that the a value is 2, the b value is negative 8, and the c value is 7. Well, it tells us a lot that is in here. The a value is a positive. That means the graph is going to open upwards. So you know that it's opening up. It's going to have a minimum value. We have a b value. The b values, without even doing the calculation yet, we know the b value is going to have some translating going on. It's going to slide to the right or it's going to slide to the left, all based off of a b value. And the c value tells you where it crosses the y-axis. So I'm pretty confident it's going to cross up here at 7. When x is 0, the y value is going to be 7. When you plug 0 into your equation, 0 squared times 2 is 0. Negative 8 times 0 is 0, and you're left with positive 7. So we're up here at 7. So you know that one pretty quick with standard form, what the y-intercept is. For us to find the axis of symmetry, we're going to do negative b over 2a. So we're doing negative 8, because that's our b value. You got the opposite of b divided by 2 times a. Notice how I have parentheses around that. 8 divided by 4, that gives us 2. So we know that we have a line of symmetry at 2. So we'll plot our line of symmetry, and we like to label that as x equals 2. Plot that down on your graph. So we know the vertex x value is going to be 2, because the vertex is on the line of symmetry. But we have to figure out where the y value is. So what do? How do we determine where the minimum or maximum value is going to be, where this vertex is located? What do we need to do? We'll plug the 2 value back into the original equation. So when x equals 2, I'm going to say 2 because that's my a value. 2 squared because it's my x squared. Minus 8 times 2 plus 7. I plug 2 in for the x for our equation. 2 times 4, because you got to square the 2 before you multiply the 2. Minus 16 plus 7. That gives us 8 minus 16, which is negative 8 plus 7. I get negative 1 when I do my calculation for finding that minimum value. We know it's a minimum because the a value is positive. So we come to our graph and we can plot that 2 to the right, negative 1 down. So our vertex, of course, is 2 comma negative 1. That's our vertex. Now we've got some thinking to do. All right, we could come over to our table, like the directions talk about, put our vertex in the middle, 2, negative 1 in the middle columns. That's an option. You can plot points to the right. You can plot points to the left. 3 and 4, 1 and 0, or any numbers you wanted to the right and any numbers you wanted to the left. Then you can start to do some calculations on that. Well, one of the calculations we already know. We know what the y value is when x is 0. We know that it is 7. It's the c value. So when x is 0, y is 7. We already determined that. We actually already graphed it. Using a reflection point, we can go, since we have to go 2 to get to the line of symmetry, we're going to go 2 past the line of symmetry. And we know that that's going to be another point. That happens to be 2 past the line of symmetry, so we're going to be 7 over here. So those are quick ways. That's called a reflection point. I didn't do a calculation to find it. I just reflected that over the line of symmetry. Now we have this other point to do. You've got 2 ways to do it. You could plug in a number and recalculate it out. That's the typical way to do it. But we can also use what you know about a parent function. A parent function from your vertex typically goes 1 to the right and 1 up. 2 to the right and 4 up. 3 to the right and 9 up. But why isn't our graph quite on that same path? Why did we have a spot way up here, but my parent function should be hitting down here? What's the difference? Why am I not there? Why am I way up here? Because we have a vertical stretch of 2. We're multiplying all our numbers by twice as much. So you might want to put down light little calculations of where your parent function would be. Really light. And now what do we do with that parent function? We stretch it by a factor of 2. We're going to push it up twice as far. And we can reflect that point. So you see we're going to have a point at 1, 1, and we're going to have a point at 3, 1. We already know what those calculations are. We didn't have to do a plug and chug to get there. You're using the parent function concept. We usually went over 2 and up 4, because 2 squared is 4. But now we're going over 2 and up 8, because it's twice as far. That makes sense. So that is where our graph is going. You should be able to do it quicker using this format than having to plug in all of those additional values. It helps out. So our equation is y equals 2x squared minus 8x plus 7. You see how I have specific dots on my grid? I want to know exactly where the points belong. If you want a table to help you organize, you can use a table. I don't think you need it. You may use it. If you're going to calculate, we had to calculate the vertex. And you see, that takes a little bit of effort. You can calculate all of these points if you want. But that's a little bit extra work. I think you can do it by just stretching the parent function. All right, we'll come down here to our next one. What do you see? What type of equation do we have? You know it's quadratic because of the 2, the square. So it's going to make a parabola. You know that it's going to be reflected over the x-axis. There is not going to be a stretch or a shrink because it's -1. It's not -2. It's just -1. You know there's some translations going on because it has a b value. The graph is going to automatically translate. So the first thing that we do is we work with our line of symmetry. So we do negative b, which is a -4, all over 2 times a. And a is -1. So that's going to give us 4 over -2, which is -2. So I have this line of symmetry at -2. So you can put that onto your graph. I would suggest to do that with a dashed line and label that as x equals -2. Once we find our line of symmetry, what do we need to do? Plug that number back into the equation. That gives us our y value. So we're going to have y equals negative, and we have to use parentheses, -2 squared minus 4 times -2 plus 2. Remember, we have to square first. So we still have the negative, and we square to get 4 plus 8, because -4, -2 is +8, plus 2. That gives us 4 plus 2 is 6. -4 plus 8, that gives us 4. Plus 2 more gives us 6. So we have a vertex at -2, comma 6. That's our vertex. So we're going to take our 2, 6, and we're going to plot it right on our graph. So we have in our table, if you like to do it, -2, 6. Pick 2 values to the right, -1 and 0. 2 values to the left, -3 and -4. You can pick any numbers you want. You don't want to go too far because we're squaring. Quadratics move so far so fast. You'll start to drop down pretty far. So you know from a parent function point of view that we go over 1 and down 1. we go over 2 and down 4. And you would have those reflection points on the other side. We could go over 3, and how far down should we go? Three in a parent function. 3 squared. If you go over 3 from the line of symmetry, not to negative 3, but to 3 to the side, that would be 9. You'd go 9, 1, 2, 3, 4, 5, 6, 7, 8, and that would actually take you off your little grid there. So that's telling you where you're trying to point. It'll be over here, I think. If you don't like finding points in that fashion, then you can go ahead and plug them in just like you did here. You know your y-intercept is at 2. When x is 0, you're at 2. Oh, look at that. Right on it. You know the line of, or the reflection point would give you a 2 out here. You could plug in your point and do it just like we did the negative 2. The opposite of squared, minus 4 times maybe negative 1 plus 2. And we see that that's at negative 1, 1, 2, 3, 4, 5. We would calculate 5 for those. You're welcome to either calculate it out, or you're welcome to use the parent function and stretching it right on your graph. I think that's going to be faster. I think that's going to be less calculations. That'll demonstrate what you understand more. The domain. Well, domain are your x values. So we know domain is all real numbers. We can use interval notation as negative infinity to infinity. And then our range is going to be from that maximum point, which is up there at 6, and it's clearly going down. So its y is less than or equal to 6. Interval notation tells us that we say the small number first and the large number second. And because it includes 6, we have to put the square bracket. It doesn't include negative infinity because negative infinity doesn't exist. Negative infinity is a concept. End behavior. As x approaches negative infinity, as we look to the right, where is the graph going? The further to the right we look, as we look to the right, where is the arrow pointing? It's pointing downwards. So we're going to negative infinity. And as x gets bigger, as x approaches positive infinity, this is the end behavior. This is what happens as we move to the right. The graph also points down. In a quadratic, it's going to point in the same direction. They're both going to point down or both point up. You're not going to have them in opposite directions because that's not a quadratic. We can tell that we had a reflection over the x-axis because that was the negative of the equation. We had no stretch or shrink because the a value was just 1. The absolute value of a was 1. We had a translation that was to our vertex, which was to the left and 6 up. And we write our equation on our graph. Negative x squared minus 4x plus 2. On the flip side, you should have one that you can do. This equation is supposed to be a little bit easier, but sometimes it gets intimidating when it's missing pieces that you're used to. You might want to consider this to be 0 for b. If you have that written in standard form like that, then your line of symmetry is going to be negative 0 over 2 times 2, which is 0 over 4, which is 0. So your line of symmetry is at x equals 0. And you label that on your graph. Then to find your vertex, we plug x equals 0 into our equation. Zero minus 5 is just 0. 2 times 0 is 0. Minus 5 is negative 5. So we're going to go down to negative 5. So we have this vertex at 0, comma, negative 5. So you can put that value into your table if you want. You can pick values to the right. You can pick values to the left. We're already at the Y-intercept, so there's not that point to find. So now what we would have to do is to actually do the math like we did here. It's not too hard. We don't have b values. But remember, we can use our parent function concept. 1 over, how far up do we go? 1 over would be 1 up, because that's 1 squared is 1. Or the other way. 2 over would be 4 up. That would be the parent function. 3 over would be 9 up. That's the parent function. Where do we want to go?
You have to multiply them by 2.
We're going to go twice as far. So instead of going 1, we're going to go 2 up. You can make that dot a lot darker. Instead of going 4 up, we're going to go twice that amount. We're going to go to 8 up. And then for the 3 over would be 9 up. Be 9 more up. That's going to be off the grid. All right, so there's your equation, 2x squared minus 5. We know our end behavior. The graph is going up whenever we look at both directions. You don't need to connect the parent function if you don't want. We're just using those points for our path, using the points to get to where we're going. Next, we're going to be looking at if the function has a minimum or maximum value. Because the a value is less than 0, the a value is negative 2, we know that the graph is going to open downwards. If the graph is going to open downwards, we know it's going to have a maximum point. It's going to have a point up high. And we're going to find this maximum value by first finding the line of symmetry. So our b values negative 10. So negative b over 2 times a, and that reduces to 5/4. And since that's 5/4, we're going to plug that back into the original equation. Square the x times the x by negative 10 and 7. So when we square a fraction, we square the top, we square the bottom. Square the top, square the bottom. Here we can reduce, and we would have negative 25, but we can reduce that to make that 8. We can double this to make the denominator 8. And if we wanted to say 56 over 8, that's the same thing as 7. So now we have common denominators. So we have negative 125 over 8. And this is going to end up positive 57. So 25 would take you down to 0. Another 25 would take you to 75. Another 6 would take you to 69. All right, I notice here that would have been a positive 10 and a negative 4. So this should have been a negative 5/4. Negative 5/4 would have made this negative, made this positive. When we square it, we get a positive. This would be a positive. This would become 75. $131. Alright, another mistake I saw here is when I reduce 5/4, this should become 5/2. Sorry about that. 5/2. 5/2. I thought it was weird we got 16 here. 25 over 4. So that's going to reduce to give us a 4 on bottom. We want a 4 on bottom, then we don't have to make this one any bigger. It's still 50 over 4. 50 over 2 actually. So that we do need to make bigger, because the denominator's got to be the same. So this is going to be 75 over 4. And we need a denominator of 4. So 4 goes into what? 4 goes into 28 7 times. When we reduce this, which would be 25 over 2. Sorry, I've totally botched this whole thing up, but I am fixing it for us. So we get 25 over 4. Well, if we have denominators of 2, we need a denominator of 2. That's 14 over 7. Wow. I did not make fractions be your friend this time. Which this gives us 39 divided by 2, which is exactly what we're looking for. Yikes, that would be 19.5, whichever format we like. So our maximum value was 39 over 2, otherwise known as 19.5. All right, for our next one, this one gives us the vertex. So we have 11 and 28. So we have our vertex. We know that the A value is greater than 0. So we have the graph opening upwards, which gives us a minimum. And the Y value is going to be a minimum at 28. This last one, we know that the A value is -2. So the graph is going to open downwards, which is going to give us a maximum value. Our line of symmetry is P plus Q divided by 2. So 1 plus -3 divided by 2, which is -1. And we plug that value back into our equation. And we get 8. 2 negatives make a positive, so that looks like it's at 8. Y equals 8 is our maximum value.